So in this video, I will go through how I made all the shaders for this project. And this is the sprite sheet shaders for the explosion and all the sprite sheet that I made in Houdini. So with this shader, all these parameters are controlled by these dynamic parameters, which we can manipulate in the Niagara particle system. So these are basically just the scalar parameter, but they are combined in our dynamic parameter with red, green, blue, and alpha channel. So the thing it can do is if I go to instance, if we see here, and if I change the, if I turn off the environment, we can change the saturation, sorry, and we can change the tint for the smoke. And all the other exposed parameters we can control in the Niagara particle. So for this sprite sheet, we have two textures. One is this emissive texture, which is the fire flame, and the another is the smoke texture. And so yeah, so with this smoke texture, no, first this material is translucent and it has index of refraction. So with this in the base color, we have smoke, and then we have desaturation, and we have scalar parameter, so we can desaturate it or desaturation and then invert it, so we can change the saturation. And then I multiplied it uh, with with a constant 3 vector, and then multiplied it with a scalar parameter, which will be the smoke intensity. So we can change the intensity, and here we can change the tint, and then it goes back to the base color. And for the emissive color, we have this emissive texture and use the desaturation node, and then inverted it, and with this scalar parameter, which is the dynamic parameter of the red channel, we can change the saturation, and then it goes to the multiply, and then this multiply goes to the particle color, which we can change the in the Niagara particle system. So we can change the color of this emission. We can turn down the saturation, and we can set whatever color we want. And then I divided it with the eye adaptation, so we can work with the auto exposure. And then this goes to the emissive color. Now for the opacity, I have made this material function called MF erosion, and what this does is it will this will use the opacity of the alpha channel of the particle color, and then we can change the um, opacity border based on the scalar parameter of the particle alpha. And the way this work is, let me open this one. So if I grab this one. By the way, this is the same as this one. It's just non-normalized because if you want non-normalized value. So if I copy this and make a new material, just to show. And if I lerp it, use this as an alpha, connect it here. And then if I go to here, get this texture, plug it in here. Where is it? Yeah. And then we will get the alpha and scalar parameter. If we save this, I set roughness to 1. Yeah. And if I save and make the material instance. So here we can change the erosion and we can control this using the alpha of the material, alpha of the particle system. And I connected this with the particle color and the texture is just the smoke alpha. And here I used the power node to and connected the dynamic parameter for the scalar value. We can use alpha power to change the power of this um, with this textures alpha, and then I multiplied it so we can have alpha multiply, and then I use the distortion for the refraction. So here we connect this thing and I multiplied it with alpha and use the depth fade. So if we get any surface near the fade distance, it will blend it will blend at the clipping area. And then we connect it into opacity. So this is the explosion flipbook texture, flipbook material. And for the dust particle, it's just simple. Use particle color and connect it to base color. And for alpha, we multiply it with the texture and put it on the opacity. And this one is also the translucent. Yeah. And yeah, this is the heat distortion. So if we get back the environment, yeah, we can see that we have heat distortion going on here. So this heat distortion is nothing but the panel texture of this water normal, which is the Unreal's starter content. And if I use lerp node and we have this, so I have a sphere mask A using texture coordinate, which is where we want this sphere mask to be, and in the B, in which position we want this sphere mask. So we want it into texture coordinate of 0.5 to 0.5, which is the middle point. And then I connected with the power node with exponential of 2 and then clamp the value between 0 and 1. And then if we see the sphere mask, we have this. And now since we have this, we could use this as an alpha and use the panner node to pen this texture with this blue color. So if we see this, we have this texture going from down to up. So that way we can connect this to the normal map, set the opacity to 0 and set it to translucent, and we can set the index of refraction, and with this thing going on we can set the index of refraction uh, with the particle color alpha, so we can use this as a uh, in the Niagara particle system, multiplied it with the depth field. So if any other surface will clip through it, it will uh, slowly blend, it will fade out, it won't just clip through. And then we use lerp node with the scalar parameter value and connect it to the refraction of index. So we have the heat wave distortion effect, and there's this spark material. There's nothing but just a particle color with connected to emissive, and the alpha of the particle color multiplied by the texture coordinate, which is we have this texture coordinate, and if we mask only green channel, which is the vertical, we have this vertical gradient, then we just invert it. So we have this, and then use the power node to intensify the gradient, and then we can just connect this to the multiply of the alpha and into opacity. But here what I used is the same sphere mask setup, but with what I learned it with the particle relative time. So if the particle dies, this value goes to 0, and that means that it will it will show the value of 1. And if the particle is alive, and this value would be 1, and it will use the sphere mask. So this is the spark structure, and we can change the color of this particle. And to show these parameters in the material in the particle system, let me show you how it works. So we have this explosion, and if I solo this main explosion flipbook, we have this, and here we have dynamic material parameters, so we can change the parameters. So we can change emission saturation, we can change the saturation like this. And for the smoke intensity, what I did here is float from curve. And then I set the smoke intensity from 0 to 1. And so in the beginning, we don't have smoke intensity, it will be mostly emissive, and then it will go from 0 to 1. And depth field, I set it to 125, and alpha multiply, I set it to 1. If we reduce it, we can make it transparent. We have another dynamic parameter as well, which is alpha power and distortion amount. So if I increase alpha power, we have this edges cutoff mode. If I set it to default, you can see how these edges go in and out. And this is the distortion. but I set the distortion to 0. We could use this one to and make the curve and make the distortion up in one frame and then let it go down so it makes the different effect. And same goes with the smokes as well. So if I set that this dust cloud, these are the sprite dust, falling dust sprite suite. And for the shock wave, we have different sprite sheet. And here we can change the other parameters as well. We can change the particle color from here as well. So